Hello, my name is Rich Whitaker. This presentation is one of two for the Lens Institute participants, which will give you information about what you can get off of maps and aerial photography that you will be downloading in the Google Earth format. This particular presentation will give you an introduction to the project, a bit about geologic and topographic maps. The second presentation will go into soils maps, aerial photography, and wetland maps. The overall idea, of course, is that there's a tremendous amount of information you can get off of maps and images, and if you're doing a study of your schoolyard, having your students read and study these maps ahead of time can lead them to ask a lot of very interesting questions. The whole purpose is that they develop testable questions before they go out into the schoolyard, and so the steps in the project lead the students through this process of looking at maps and asking questions. For example, easy questions to deal with would be, where does the water come from that goes across your schoolyard? How does it cross the yard? Of course, downspouts are easy to find, maybe flooded areas and the water passing a sheet flow across certain fields. What's interesting not only is where does it go, but also what does it carry in terms of both sediment and maybe contamination. A second question that can be asked almost anywhere is, if you go and dig a hole in any parts of your yard, what are you likely to find? This, of course, is a more geological kind of question, and you can get a lot of information off of topographic maps and geologic maps and soil maps to give you an idea what you might find before you get to your particular spot. If you happen to have a wet area on your property, it might even be just a ditch, but perhaps it's a pond or a creek or a wetland, you can ask all sorts of questions then about the relationships between the water, the sediments, the soil, and the plants, because there's a very dramatic difference that you can very often see in the shallow soils if you have a real difference in saturation. So these are the kind of maps that have information about all of these kind of topics to some degree. In this particular presentation, we're going to focus on the geologic and the topographic maps. The two sources of information for geologic maps, the folks at USGS and the folks at the Charlottesville office of the Division of Mineral Resources, which is our state survey, have been putting out maps over the years, including a very large scaled geologic map for the whole state. That map has been simplified somewhat and digitized and put into Google Earth, and there are maps that you can get like this for all of the states, but the one for Virginia is the one we're going to take a look at in our project, and it looks something like this. You can see, of course, a lot of gaudy colors here, which is typical for a geologic map, but you will find there's a lot of very good information here if you're really just looking at very broad scale. I want to show you an example of that. Here's a close-up, for example, of the area in and around Blacksburg and Christiansburg. You can see the different colors there, all of which are largely limestone and dolomite, carbonate rocks. There are faults and a few other things you can see here, but if you zoom in closer, you don't get much more information than this. So it's very good for broad-scale information about rock types, but for detailed information you'll have to go back to those agencies and get more detailed maps. Topographic map information, of course, is best supplied from the USGS. There are a variety of ways of getting it in paper or digital format, and a variety of vendors who will supply it to you. What we find on the Google Earth format are copies of the 1 to 24,000 maps that are very, very useful, and being free makes it particularly handy. It is extremely important to recognize, though, that these maps were originally drawn for that large-scale paper version, which is at 1 to 24,000. It is accurate if you consider that 2,000 feet on the field would be 1 inch on the map. If you try to blow the map up to very fine scale and still try to use it, it has a much lower sense of accuracy. It's very easy to do digitally, and you can get yourself into trouble if you try to think it is more accurate than it is. So when you're looking at the maps then, of course, there's a lot of cultural features that can be found. The red and black lines were drawn on the original map, perhaps done back in the 60s from aerial photographs available at that time. Those were field checked to some degree. You'll also find then revisions to the maps have been done, and where new aerial photography has been obtained, particularly in areas where there's a lot of growth of buildings and subdivisions and so on, you'll have purple added with each new revision. Blue information, of course, is water. You can see a variety of water features there, as you have on this map, such as the estuaries, both perennial and intermittent streams with different style of colors. The wetlands have the little grassy symbol, and of course ponds are little irregular round blobs. What we're mostly going to be looking at, though, are the contour lines, which are brown. If you have darker brown lines, those are the ones with the numbers on them. If you have a paper copy, you're able to look at the bottom of the line and see what the contour interval is. In other words, what is the difference in elevation between each brown line. With digital copies, you don't have that luxury. You've got to go looking and see what the labels are on every fifth line. Those are usually marked in darker colors. Index contours will have specific values on them, but you have to count you have to count the lines between. There are 5 lines between every index contour, and only the index contours are labeled. So in this case, there are labels on the 50s and the 100s, so the contour interval is 10 feet. What we're going to mostly look at these maps for, though, are the differences in how closely spaced the brown lines are positioned. If they're closely spaced, it is steep topography, and where they're very broadly spaced or not there at all, of course, it's quite flat. You will need to appreciate that the steep lines are formed by erosion by 2 different processes in Virginia. Very commonly, you've got streams cutting down valleys, like you see here off on the left, and over on the right you have some cliffs that were formed by wave erosion coming across during storms across the estuary. So the steep lines show signs of areas where there's relatively recent erosion. Flat areas show where there's been periods of deposition, either down in the stream valleys like you see there by the creek, or up on the hilltops down in the western left circle. And we will talk more about those later, but those are zones of deposition, usually caused by sediment accreting in the bottom of river valleys or on the bottom of oceans, and we now find those abandoned ocean surfaces as high terraces. A couple other things about topographic maps can be seen here in the Goochland area. Example, you can see some of the steep and the flatter areas, again showing different gradients and also then areas of erosion and deposition. But an equally important feature are the shapes of the contours. Here you can see many of the brown contours have these very sharp kinks in them, or V's. They mark valleys that streams have carved into them. There are streams running up these V's, even though they're not shown as blue lines. Those would be where the ephemeral streams would be, streams that are running only right after a rainstorm. But you can trace out the path of these V's very nicely, and you will see almost all the time they connect up into an organized dendritic drainage pattern. That is how we know that this particular area would be the watershed, and the slopes within this area then are the ones that pass water down to the creek from off the hillside. So water and sediment washes off of these slopes all the time, and that's why we say the slopes are also being eroded by the stream system. The entire watershed, of course, is marked out by the outer edge of that drainage system. So here in the Goochland area, you can trace down some number of these streams through the V's and see where they flow down to the river. And of course, this would be an area down below where a lot of deposition would have occurred in the flat. So the flat valley floors are a place where stream sediments would have been deposited. So topographic maps then tell us a great deal, principally about stream, valley patterns, slope directions, water flow directions, and they can also indicate for us at this scale of map some relatively large areas with original deposition surfaces or areas where there's been relatively recent erosion. This is the end of this particular presentation. We're going to talk about aerial photography, wetland maps, and soil maps on the next version of this.